Q8086. Direct mechanical push-pull carburetor heat control linkages should normally be adjusted so that the stop located on the diverter valve will be contacted. A. Before the stop at the control lever is reached in both hot and cold positions. B. Before the stop at the control lever is reached in the hot position and after the stop at the control lever is reached in the cold position. C. After the stop at the control lever is reached in both hot and cold positions. The correct answer is A. In a direct mechanical push-pull carburetor system, the heat control linkages are responsible for adjusting the flow of heated air to the carburetor to control the engine's temperature. The heat control lever is typically located in the cockpit and is used to regulate the position of the diverter valve, which diverts or bypasses the flow of heated air. By adjusting the linkages, it is important to ensure that the stop on the diverter valve is contacted before the stop at the control lever is reached in both the hot and cold positions. This adjustment is necessary to ensure that the diverter valve is properly positioned to control the flow of heated air to the carburetor. If the stop on the diverter valve is not contacted before the stop at the control lever is reached, it may result in improper or inadequate control of the heated air flow. This can affect the engine's temperature regulation and performance. It's worth noting that specific carburetor systems may have variations in their linkage designs and adjustment procedures. It is always recommended to refer to the aircraft's maintenance manual or consult with a qualified technician to ensure the correct adjustment of the heat control linkages for a particular carburetor system. Q8087. Reduced air density at high altitude has a decided effect on carburation, resulting in a reduction of engine power by A. Excessively enriching the fuel-air mixture. B. Excessively leaning the fuel-air mixture. C. Reducing fuel vaporization. The correct answer is A. An aeroplane engine generates power by burning a mixture of fuel and air inside engine cylinders, turning the chemical energy in the fuel into heat energy. The ratio of the weights of the fuel and air in the mixture determines how effectively this energy exchange occurs. Because the air at high altitude is less dense than the air at sea level, which weighs more, the same amount of fuel will result in an abnormally rich fuel-air mixture at high altitude. For the highest efficient production, there will be too much fuel per pound of air. Q8088. Increased water vapor. Higher relative humidity in the incoming air to a reciprocating engine will normally result in which of the following? A. Decreased engine power at a constant RPM and manifold pressure. B. Increased power output due to increased volumetric efficiency. C. A leaning effect on engines which use no automatic carburetors. The correct answer is A. When the incoming air has a higher relative humidity, it means that the air contains more moisture or water vapor. This increased moisture content can have several effects on the performance of a reciprocating engine. Firstly, water vapor takes up space within the combustion chamber, reducing the amount of available air for combustion. This results in a decrease in the volumetric efficiency of the engine, which is the ability to draw in a greater volume of air for a given displacement. As a result, the engine may experience a reduction in power output at a constant RPM and manifold pressure. Secondly, water vapor has a cooling effect during the combustion process. It absorbs heat energy from the combustion chamber, reducing the temperature of the combustion gases. Cooler gases have a lower pressure, which leads to a decrease in the power output of the engine. Lastly, increased water vapor in the incoming air can also have a leaning effect on engines that use non-automatic carburetors. The water vapor displaces some of the oxygen within the air-fuel mixture, resulting in a relatively richer fuel-to-air ratio. To maintain the desired fuel-to-air ratio, the carburetor may need to be adjusted to provide a slightly leaner mixture. Q8089. 1. Preignition is caused by improper ignition timing. 2. Detonation occurs when an area of the combustion chamber becomes incandescent and ignites the fuel-air mixture in advance of normal timed ignition. Regarding the above statements, A. Only one is true. B. Both 1 and 2 are true. C. Neither 1 nor 2 is true. The correct answer is C. The first claim is untrue. Preignition is the ignition of the fuel-air mixture earlier than the usual ignition is scheduled to take place. It is brought on by flammable materials inside the cylinder. Carbon particles may become incandescent and ignite the mixture early as a result of detonation because detonation generates enough heat in a cylinder. The second claim is untrue. Detonation is the unburned charge's spontaneous combustion in advance of the flame front following ignition. Preignition can make the fuel-air combination burn in the cylinder for a long enough period of time to raise the unburned mixture's temperature to a critical level. It no longer burns, but bursts at this moment. This sudden release of energy has the potential to overheat the cylinder and generate enough pressure to break the piston and connecting rod. 8090. Which of the following engine servicing operations generally requires engine pre-oiling prior to starting the engine? A. Engine oil and filter change. B. Engine installation. C. Replacement of oil lines. The correct answer is B. When an engine is being installed or reinstalled into an aircraft or a vehicle, it is necessary to pre-oil the engine before starting it. Engine pre-oiling involves priming the engine with oil to ensure proper lubrication of the internal components before the engine is cranked or started. During the installation process, the engine is typically disconnected from the oil supply, and there can be air pockets or dry areas within the lubrication system. If the engine is started without pre-oiling, it can lead to a momentary lack of lubrication in critical areas, causing excessive wear or damage to the engine components. By pre-oiling the engine, the lubrication system is filled with oil, ensuring that all the internal parts are adequately lubricated before the engine is started. This helps to minimize friction, reduce wear, and maintain the longevity of the engine.